Welcome again to our next lesson. Today we are going to discuss about 82C55 or sometimes we say 8255 peripheral IC. Okay, so it's called programmable peripheral IC. Okay, keep in your mind programmable, that means this IC is programmable. 2. Peripheral, that means it's used for I/O interfacing. IC means it's an electronics IC, so should have some electronics characteristic. Okay. Now, before going to this lesson, before going to this discussion, I would like to mention two things. Keep in your mind, one thing is serial and parallel communication. You know what is serial communication? One device to another device, data will go serially. Parallel communication, 8-bit or 16-bit or 32-bit data will transfer at a time in one clock cycle. Okay, this is one thing. Another thing is, you have to keep in your mind, there can have two types of communication. One is just live, or you can say real-time communication. You will just send something, it will receive it. Okay, just send something, receiving. And another one can be handshaking. Okay, handshaking means you have to call someone, they have to respond, like in our cell phone, when we will call someone, then they have to respond. So this kind of, we call it handshaking communication. Okay, so this IC 82C55, this supports both of these real-time communication for low-level devices and also handshaking communication, handshaking input or output. Okay, so let's read the features of it. So, according to this information, we found that this is a very popular common interfacing IC that can be used for very low-level interfacing like 7/7 display, LED, or even the stepper motor or some other DC motor controlling. Okay, to high-level interfacing, like we call it peripheral, like keyboard, mouse, this kind of things. Okay, so it can be useful all over this thing. Now, as this is a IC, we need to know the pin configuration. Take a look in this figure. Before discussing this thing, I would like to discuss you this figure. Okay, take a look. 82C55 is an interfacing IC. On right side, there are three ports. Port A, Port B, Port C. And also it has a communication with microcontroller unit, microprocessing unit. Okay, all these ports are 8-bit. Okay, 8-bit. Each port is 8-bit port. Okay, now take a look. 3 ports, 8-bit. That means how many pins? 24. Okay, then for data communication with the microprocessing unit, 8-bit port, which is called data bus. Okay, data port, 8-bit. So 24 plus 8, 32. It's an electronics device, so it needs VCC and ground. So 32 plus 2, 34. Okay, and it requires some control connections. You can see here, read, write, A0, A1, read, write, processor will send the read command or write command to the interfacing IC. Okay, for read, write, and then reset to reset this programmable peripheral device, and also the chip select. Chip select means when it will select this chip, then this chip will work. Otherwise, this chip will not work. Okay, and there are another 2 pins. One is A0 and A1. This is mainly used for selecting the port. So we have 3 ports here, port A, port B, port C. So if A0, A1 is 00, then it's mentioning A, then B, then C. So there is another configuration 1, 1. Okay, When we will configure 1, 1 on A0 and A1, it will write the data on the register stored inside it. Okay, so that means there is a register, we can say control word inside this chip that can be written when we will configure A0, A1 as 1, 1. So now take a look in this pin configuration. You can see there are 8 pins for port A, which is 1, 2, 3, 4 and 37, 38, 39, 40. Then 8 pins for port B like 18, 19, 20, 21, 22, 23, 24, 25. And 8 pins for port C, which is from 10 to 17. 8 pins for data communication with the microprocessing unit, which is from 27 to 34. And yeah, there are VCC and ground on 26 and 7. Read and write is on 5 and 36. Chip select on 6 and reset on 35. A0, A1 on 8 and 9. So, here's the information. This device has 24 pin for I/O. Port A, port B, port C, 8, 8, 8, 24 pin. The I/O pins can be programmed in a group of 12 pins. This thing I didn't mention before. That means we have 3 ports, but it can be divided into 2 groups. So if we divide into 2 groups, 12 pins in a group and 12 pins in other group. You can see here port A and 4 pins of port C will be, we are saying it port C upper. This is in a group A, and port B plus 4 pins of port C lower is in group B. Okay. Another information is it can operate in 3 modes. One is mode 0, 1 and 2. Okay. We are going to discuss what is mode 0, what is mode 1, what is mode 2 later. Okay. So, as I told you, the group is divided into 2 groups. Now, let us understand the pin configuration. I already mentioned you. One is, so D0 to D7 is communication with microprocessing unit. CS is chip select, read. So when processor will give read command, this device will send data to the processor. When microprocessor will send write command, then microprocessor is going to send some data to the 82C55. So this is the connection. Okay, so in the middle, this is 82C55. On left, it's microprocessing unit, and on right, we will be able to use some I/O device like even keyboard, mouse, or 7-segment display, or LED, something like this. Okay, so this is the interfacing diagram. Here I am showing like port A and port C upper is in group A, and port B and port C lower is in group B. Okay. Now let us discuss about this block diagram. This is also this is the description of the previous one. You see, all the control connections are on left, and the data connection. So that means there is a microprocessing unit on left, and on the top you can see VCC and ground. Okay, and let us have the discussion on this group and the ports. So you can see the control connections are divided into 2 groups. One is group A control and group B control, and of course under group A should have port A and port C upper, and under group B should have port B and port C lower. Okay, and there are some bus connections. You can understand it. Okay, so sometime this kind of figure comes to your exam. Okay, so please remember these figures. Okay, not so difficult. There are, so you can see bus connections have with every ports there are bus connections, but control connections you need to keep in your mind which control connections will be connected with which one. Okay. Now, data bus buffer. Okay, what is buffer? to store something for a while. Okay, so it's a 8-bit bidirectional data bus. Okay, that means we are talking about D0 to D7. Okay, the data bus with the microprocessing unit. It's an 8-bit data bus used to interface between 82C55 data bus with system bus. That means system bus means the bus of microprocessor. The internal data bus and outer pins D0 to D7 pins are connected internally. Okay, you can recognize this thing. The direction of data bus buffer is decided by the read or write command. Okay. Now group A and B get the control signal from CPU and send the command to the individual control block. Okay, so this is the description of that block diagram. Group A send the control signal to port A and port C upper, and group B send the control signal to port B and port C lower, as I told you on that slide. Port A, this is 8-bit buffered I/O latch. Buffer means like, you know, fan out and fan in issue. When someone is give 0 or 1, 0 means around 1 volt, 1 means more than 3.5 volt. If this is the buffer, if it gets 3.7 volt, it will provide 5 volt. Okay. In the same way, if it gets around 0, it will provide the voltage is assigned for 0. Okay. So that is buffer. And how about the latch? Latch means you have given 1. Okay. And you withdraw the input. There is nothing. No 0, not 1. Okay. Floating. You make it floating. But it will still providing you the output 1 until you change it. When you will change it as 0, then it will start giving you 0 continuously. So it's like a memory. Like a memory. When you will give something, it will remember. It will not forget. Then when you will change it, then it will remember the changed input. So as they told here, group A or port A, the pins are latched, okay, buffered and latched. So it can work in mode 0, mode 1 and mode 2. Okay, so we came to another word is mode. Mode, important word. So there are 3 modes. Okay, it supports 3 modes. One is mode 0. Mode 0 means normal input output. Okay, switch, LED, 7-segment display, this kind of normal I/O device. Mode 1 is handshaking in or out. And in mode 2, it will support bidirectional. Like if you want to receive some data, you can receive. If you want to send data, you can send. Okay, not in the same clock cycle, but it support. Okay, port B is just like port A, but it doesn't support mode 2. Okay, it just support mode 0 and 1. Okay, but port C only support mode 0. Okay, it don't support mode 1 or mode 2. But the interesting thing is, the pins of port C is used for handshaking 0. That means when port A works in handshaking in, then 3 pins from port C will perform that handshaking task. Okay, the control task of handshaking. In the same way, when port B will do some output or input work, at that time, some pins of port C will support for handshaking. Okay, so port A supports mode 0, 1, 2. Port B supports 0 and 1. Port C support only 0, but in mode 1 and 2, it used for handshaking. Okay, this is important issue. I think I will discuss the next part in the next discussion session.